Alright, the next thing that we're going to look at is adding and subtracting rational expressions. In this section, in this presentation, we're going to look at only rational expressions with same denominator. This comes from section 6.2 of your textbook. Okay, the first thing that we're going to look at is adding rational expressions. In order to do this, we want to combine into a single fraction by adding the numerators and keeping the denominator. We are going to combine like terms, we're going to add the polynomials, and then we want to simplify the fraction. In order to do that, we're going to factor the top and bottom if possible, and cancel any common factors. Alright, so let's go ahead and look at some examples. If we look at example A, we have 2x minus 1 over 3 plus x plus 4 over 3. Note that we have same denominators, and so we can go ahead and combine this into a single fraction. If we do that, we get 2x minus 1 plus x plus 4 over 3. From here, we want to go ahead and simplify the tops, so we're going to combine our like terms. What can be combined? We can combine 2x and x. This gives me 3x. We can also combine negative 1 and 4. Negative 1 plus 4 is 3. From here, I can factor out a 3 on the top. If we factor out a 3, we are left with x plus 1 inside the parentheses, and then now I can cancel my 3's. My final answer is x plus 1. Alright, let's come over to example B. Example B, I'm going to start by combining this into a single fraction. I'm also going to go ahead and rearrange the top. So I'm going to have x squared. I'm going to switch my negative 6x and my positive 9 so that this is in descending order. We keep the bottom. From here, I want to go ahead and factor. So the top, this is a perfect square trinomial. Things that multiply to x squared is x and x. Things that multiply to 9 are 3 and 3. Positive 9 tells me same signs. We are combining to a negative 6, so they are both going to be negative. That's my numerator. Now my denominator is going to be difference of squares. So we have x and x. Things that multiply to 9 are 3 and 3. And with difference of squares, we're going to have different signs. Finally, I want to cancel my common factors. So I can cancel an x minus 3. And my final answer is x minus 3 over x plus 3. All right, let's go ahead and talk about subtraction now. In order to subtract rational expressions, we want to combine into a single fraction. We're going to distribute the negative. From there, we will go ahead and combine like terms. We're going to simplify the fraction, we want to factor the top and bottom if possible. And then we want to cancel any common factors. All right, so let's go ahead and look at some examples. Example C, I'm going to go ahead and combine into a single fraction. So we get 2x plus 3 minus x all over x plus 1. I can combine my like terms. I can combine 2x and minus x. This gives me x plus 3 over x plus 1. This does not simplify any further, and so this will be our final answer. All right, if we look at example D, the first thing I want to do is combine into a single fraction. And one of the things that we do want to be careful about here is we want to make sure that we apply our negative to all of the terms in the second fraction. So this is actually going to become minus 4x plus 2. If we distribute our negative, remember to change both signs. Denominator is the same, so we're going to go ahead and keep it. And then now if we go ahead and combine our like terms, we have 5x minus 4x is x. We have plus 1 and plus 2 combined to give me plus 3 over x squared minus 9. The denominator does factor. It is difference of squares, so we're going to factor it. We get x and x, 3 and 3, and we have different signs. If I cancel my common factors, I cancel x plus 3's. And then now what is going to be my final answer? You do want to be careful here. We have an x minus 3 on the bottom, but what do we have on the top? Well, remember that when we cancel common factors, we are dividing. And so what we are left with is we are left with 1 over x minus 3. All right, last example. Starting off with, we're going to go ahead and combine our like terms. I get 20y squared plus 5y plus 1. Remember that we want to distribute our negative to each one of these terms. So this is going to become minus 8y squared plus 12y, I'm going to change the sign, plus 5. Our denominators are the same, so I'm going to go ahead and keep it. And then we go ahead and combine our like terms. So we have 20y squared minus 8y squared gives me 12y squared. We have 5y and 12y combined to give me 17y. And then we also have 1, and 5 combine to give me plus 6. Our denominator stays the same. And then now I do want to go ahead and factor this if possible. I'm going to start with the denominator. It looks a little bit easier to factor. I think that for 6y squared, I'm going to go with 3y and 2y. Things that multiply to 2 are 1 and 2. 2 cannot go in the second set because that would mean that we would have a common factor there. So I'm going to put it in the first set. So we get 2 and 1. We are multiplying to a negative 2, which means different signs. I want my larger quantity to be positive, so which one is larger? My outsides, 3y times 1, which is 3y, or 2 times 2y, which is 4y. Since 4y is larger, I want my 2 to be positive, and I want my 1 to be negative. Okay, so now I want to try this as one of my factors for the top. Quick note, we are multiplying to a positive 6, which means same signs. We are combining to a positive 17, which means both are positive. That rules out the 2y minus 1. So I'm going to go with 3y plus 2. If we go with 3y plus 2, we have 12y squared is equal to 3y times 4y. And we have positive 6 is equal to positive 2 times positive 3. If we do a quick check to make sure this is correct, outsides I get 3y times 3 is 9y. Insides, I get 2 times 4y is positive 8y, and that does in fact combine to 17y. Alright, so we go ahead and cancel our common factors. We can cancel a 3y plus 2, which leaves us with 4y plus 3 over 2y minus 1 as our final answer. And that takes care of subtracting rational expressions.